Okay, so starting off with the singleton design pattern. So first of all, we look at why do we need singleton design pattern? Mainly to ensure that class only has one instance, and then if that is the case, then we can provide the global point of access to that instance. So if you want to control access to shared resources such as a database connection or a configuration manager, meaning that uh, if your application deals with a database, and if you have multiple connections to the database, then what will happen is there will be data concurrency issues, right? So one process might update the database while some other process is trying to read it, or rather two updates can happen in the same time, right? And also configuration managers, things like application settings, like how many I mean what is the number of uh, processes that are allowed, right? What is the maximum file size that are allowed to this system? What is the sort of memory that maximum memory or other range of memory that this system is using? Things like that you have to store it in a application settings somewhere in an application. So usually we don't store those kind of settings in the database. Those are stored in within some sort of an maybe environment variable. So maybe in a local file in your application. Uh, so you have to sort of maintain one copy of that application settings. If there are multiple copies, then again that problem occurs with database or other reading or maintaining concurrency, right? So to address that issue, we need to ensure that the instance of that class is the only instance, and we should not allow creating multiple instances using the same class, right? So that is the idea behind singleton. For the solution for that, as I mentioned, we need to create a private static instance of the class, because if we create a uh, static instance, then you know that if this instance is static, then there should be only one copy of that instance, and that copy is shared among all the objects. But then again we have to stop creating other objects, or rather using this class to create multiple objects. So to do that, we need to create a private constructor. So if the construct of the class is private, then then we cannot instantiate this class using the new keyword, or rather create objects from this class using the new keyword. So we can do that, and then we can provide a public static method so that we can access that created single instance, right? So to summarize that, the singleton pattern ensures that the class has only one instance and provide a global access point. So as a real world example, think of it as a president's office. There is only one president in a country, right? There can't be two presidents at the same time, and everyone can access that president's office or president through a single instance, right? So it is like that. The office of the president and president itself. So president is our instance of the class, and this public access point that we are trying to create is the entrance to that president's office. Okay, so we'll try to implement this. Let's create a public class called the president, and then we'll create a private static instance of this class. So as I mentioned, this is to make sure that you don't to create a single instance, right? So rather than having multiple copies of the single instance, you have to mark this instance as a static instance. So only one instance will be created, right? And then we'll create a private constructor and then we will create a public static method to get this instance with a getter. So here if we have a check whether the instance is null, because at the beginning there won't be any instances of this class created. So we'll first of all check if the instance is null, and if it is null only we will return a new instance of this class. Otherwise we'll return the existing instance, right? So if you go through the code again, we have a private static instance of, or rather reference variable for this instance. Then we have the private constructor, so that we cannot create instances of the president class outside of this class using the new keyword. And then we have a public access point, or the public static president is the return type, and then we have this to get the existing instance, existing instance. And if there is not uh, existing instance, or there are no instances created before this, we'll check if check that by using comparing it to null, and if it is the case then we'll create a new precedent. Otherwise we'll return the existing instance. So to check if this is the case, let's try to implement, rather access this instance using two different ways, and just compare it to see if those instances are the same thing, right? So first of all we'll create a instance precedent. So this instance is a property of that class. So as you remember, so we created this uh, getter method. So we are accessing it the first time, and then we are trying to access it the second time as well using another variable called precedent 2. So if those two, precedent 1 and precedent 2, are the same thing, then we can say that we have successfully implemented the singleton design pattern, right? So we'll compare it using this um, in this code segment here. So if this is equal to this, it will be printed as true. Let's run it and see if this is the case. Yeah, so it is coming as true. So that is how we are going to implement the singleton design pattern. So after implementing it, we have provided a single access point to control this instance, and it initializes the instance when the first time it is requested, not before. So we have to actually request the instance, otherwise it will not initialize, as I mentioned in here, right? So we have to call this instance getter to initialize it, otherwise it will not be instantiated, right? And can lead to issues with multi-threaded access. So if a single instance is requested by multiple threads, then there will be issues, sort of performance hits for your application. So for those things you will need to implement synchronization and things like that to access this created instance. Otherwise there won't be an issue. As I mentioned earlier, so this singleton pattern solves the problem where you need to have one class only or one instance only. It will not think about other problems that will come by using it, because our problem is that. So now we have a solution for that. So only if you want to solve that specific problem, you will be using singleton. And if this is also a problem, then you will have to go to another design pattern, or rather some other implementation, right? So that is the main idea behind it. So yeah, also due to the tight coupling, it will take some time, or rather difficult to do the unit testing as well. So you don't have to worry about all these things. The main idea of this singleton, or the main takeaway, is that so now there's only one instance of the object, So if it becomes corrupted, the entire system is compromised sometimes, right? So since you only have one object due to some other issue, maybe hardware issue or memory problem in a uh, computer, or um, uh, the system that you are running this program, this instance will or might get corrupted. And if that is the case, your system, I mean your application will break, right? So that is that trade-off. But anyway, this singleton is providing a solution to a problem, so we have solved it.